Okay, tell me from last week program solving classes. I hope you guys still remember some of the things. Those are like basics. Anyone can tell me what are like data types? Data types. What is data types? Anyone? Okay, just say data. What is data? What do you understand when I say data?
Information.
Information. Is data and information same?
Really? Collection of information.
Sorry, I couldn't hear you. What did you say?
Collection of informations.
Collection of information is what?
Data, ma'am.
Data.
Okay, data types.
Types of information stored.
uh, like for example, the integer, character, floating, float. We have those are data types.
Okay. So, and what is data structure? Any idea?
Uh,
Any idea?
Data structure. Ma'am.
Okay, I'll leave it. You guys remember algorithm, right? What is
Yes, ma'am.
algorithm?
Ma'am, algorithm. It is the simple uh, form to
Easiest
show
way.
the simple form to show the functioning of a program
Okay. It's like step by step method, right?
step by step. Yes, ma'am.
Step by
So,
step.
can you just think about the relationship between a data and algorithm, how they are interrelated?
Uh, Data and algorithm, and the way the data is being processed and given as output, those steps we call as algorithm. Means if when the program is executing, we execute it.
Good. See, for any programming or any programming code, you always give some input data, right? So
Yes, ma'am.
using that algorithm, you solve a problem and give the data. So algorithm is like how you are going to use that data.
Yes, ma'am.
So you say data already. What is data item?
Data and
See, data is like simple values or
yes,
set of values, right? So data item will be, just think about a set of numbers. Suppose 1, 2, 3, 4, 5. Then
yes, ma'am.
data items will be the single unit of
Integer
those values.
single units.
So, and then there's another term, group items. Group item means suppose you can divide your data into some subgroups. Okay, then
Yes, ma'am.
those data items will be like group items. Suppose your name you can divide into first name, middle name, and last name, right?
Yes, ma'am.
So since your name can be divided into some sub items, that means your name is a group items. Then some other data like your enrollment ID or roll number. So those data items we cannot divide. So those are known as elementary items. Okay. Then do you
Yes.
know what is entity?
And type two.
Any idea? Anyone?
Now where we have to put digits as data.
Correct. Almost there. Is it only digits?
Digits and alphabet, I guess.
Yes, it can be both numeric and
Yeah, yeah,
non-numeric.
yeah.
So entities are like something you have attributes. We call the term attributes. Suppose when you fill up your form, then you have your name, age, then enrollment ID and all. So whole thing that form is an entity. Then your name, age, enrollment ID, those are attributes. So then when you input the values for those attributes, then those are values. Means for the name you will of course put your name, right? So your name will be values, but that heading name, that will be attribute. Then if you have similar attributes in the form, then that will be an entity set. Is it clear? Till now, just data, data item, group items, elementary items, and entity. Is everyone copying?
Sorry.
Sabe বুজি পাইছানে? Any doubt?
Yes, ma'am, got it.
Now, those are like small, small things here. Now, if I say like record, any idea what are the things you will call record?
A collection of data which is stored in
Collection of what?
data.
The collection of values in an
Okay.
entity or record. Suppose your student
It
record.
contains all the data.
Yes.
It contains all the data.
Yes. When we say like we are keeping record of students, like I gave you a form to fill up, so I am collecting all the information of your students. So those are for my record. So data, data item, then entity, those are small, small things. Then in the end, I get the complete record. Then file, what will be the file? What will be the file?
Mm,
Just think about your own file, what you put inside the file.
ma'am, information.
Data.
Records.
Oh yes, records.
So go from step by step. First you have data, then you have whole entity, then those entities will have attributes, then values, then those things will, that information will create a record. Then those record you will keep in a file. Suppose if I maintain a file like CSE student, then there will be different records. Record for third SEM, record for fifth SEM, then record for 7 SEM, like that. Then again within that record there will be different part, like for third SEM we will have your records, then again in that form we'll have entity, then data. So data is like the smallest unit of all the files or anything. Okay, and file is the largest set of all the data.
Data.
So last time in programming, you already mentioned like in float and uh, those normal data. What are those
Ma'am, these are data types.
data types, right? So those are also called your primitive data types. Okay. If you
Primitive.
remember last time we mentioned that we have data types like primitive or derived data types.
Yes,
Right?
ma'am.
So what will be the data structure then? See, I have already told that how we arrange a data. First data, then comes entity, then comes record, then files. Then what is data structure?
Ma'am, organized way to store data.
Yes,
Of
correct.
data values.
Right.
Collection
So
of all the data values.
yes, so data structure is just a way to store and organize data so that it can be used efficiently.
Yes, ma'am.
Okay. Okay. So data structure can be of two types. One is
Yes, ma'am.
primitive data type and one is non-primitive data
No,
structures. So primitive data structures are those you already mentioned.
array, array,
Fundamental types. No, array is non-primitive one. Primitive
non-primitive. Okay.
are those fundamental data types like your integer, those built-in data types. Okay, and these built-in data types you cannot divide. Built-in data types, your integers, boolean values, floating, string, characters, those are primitive data structures. So those about those things you have already learned in the last last semester. So this semester you are going to learn about non-primitive data structures. Okay. So non-primitive data structure, what are those? Those are mainly created using the primitive data structures, and these are also called derived data types.
Yes, ma'am.
So non-primitive will be like list, array, stack, queue, all those things you are going to learn as a one unit. Okay, so this is like the basic things. And using, suppose if you remember the array you already learned last time. So what was array?
Array was a collection of
Collection of
organized
all organized what?
uh,
Management. Mm, sorry.
Someone's
common
having that
data.
yeah, organized same type of data.
Same data.
Okay. And list is also similar. It's also a collection of similar type of data. There is, if you remember, in array we always represent it using index. Remember, if you
Yes, ma'am.
initialize an array, when you call for a particular item in an array, you always define it using the index. Like A0 will be like your first item in an array. Now, non-primitive data structures can be again divided into two types: linear data structures and non-linear data structures. Okay, linear means what
Or I
could
can
be the
say
linear one?
So it's
Linear,
it's stored like in a sequence
list.
yes,
and
correct. So if you organize your data sequentially, means in sequence, then it will be linear data structure. So there will be two ways to represent those in memory. Like suppose in sequential memory location, like your array you just keep things in sequential order. Suppose if I ask you to add 10 consecutive numbers, you will store the values like 1, 2, 3, 4, 5 up to 10, right? Those are stored sequentially. Okay. Then there can be another way, means it can have pointers or link. So when you have pointers or link, then those type of data structures are called linked list. Linked list you will get to know about like maybe second unit. I'm just giving the briefing now. All of these data structure have a one thing. So linear structures are those are organized in a linear fashion. And non-linear data structures, simple.
Those are
Those are
not
yes, those are not
those are not
arranged in sequence.
sequence.
So anyone can give any example of non-linear data structure? Who said that?
of registration form.
Registration form. Mm, not exactly.
And graphs and trees.
Yes, correct.
Yeah.
Your nonlinear data structures are like trees and graph. Have you heard of
Graph.
trees? Tree?
No.
No, man.
Tree, okay.
No, man.
Tree and graph. Graph, I guess you have already heard about it.
Mm.
Okay. So, in case of nonlinear data structure, they sometimes or most of the times they are just arranged in a hierarchical relationship. Means for graph, you can think about your flight. Suppose one flight is going from Guwahati to Chennai. So suppose the flight will first go to Kolkata, then will go to Delhi, then will go to Chennai. So all the flights have certain routes, right? And they always follow that route. So those interconnected destination means points are called nodes. You can also think about your Facebook account. Like Facebook also use that graph data structure. When you open an account, then there will be your friend list, then your like videos, then your photos. So all of those things are arranged in a graph order. Means suppose you are the main node, then from you
Mm.
then will be different links. From you we can connect to your other friends. That's how also recommendation system works. Like based on your likes, your online shopping sites, they always recommend you something, right? So every time you check out something, then they just keep records, and based on those things, they keep showing things. Or suppose like in Netflix, suppose 2 or 3% are using same Netflix account, so they will keep checking who is watching what type of movies. So based on your friends choices, they can also just give you suggestion that your friend like this, you can check this one too. So and in Facebook also you get friend recommendation, right? Suggestion like this friend, you have mutual friend with him, so they just suggest you friends. So those are non-linear data structure, and mostly they use graph or sometimes also use tree. Okay, so anyone can say what will be the advantage of using such data structures?
We can find
Just
information easily.
in what?
Right, the information we can search the information very easily if it's organized in a way.
Yeah, so you can say they are using memory efficiently, right? Optimize memory utilization. Your point is correct. Then anyone else?
Allows safe storage of informations.
Sorry, I didn't hear your voice completely.
It
It,
allows safe storage of informations.
yeah, storage of information is the basic things. Main point of a data structure is organizing and storing. So, what will be the advantage? When you said efficient memory utilization, right? So other can be you can reuse those data structure over and over again. Suppose you have created an array, same array you can use for different record as well, right? Like even the graph thing, you can use that graph for other things also. Suppose just now I told for the Facebook one, you have opened an account, so you will have friend, then save graph, you can add and delete things there. So it's easier to reuse those data structures. Okay. Then third one, anyone want to say or try?
allow for system data.
Allows what?
processing of data.
Uh, that's also correct. It's like it helps us to process data very easily, and it's like defines the physical form of abstract data types. Like abstract data types, you have all in Boolean those values, so it's easier to maintain them also. So it's like gives abstraction of the data. Okay, so now there will be certain operations as well. Operations like traversing, searching, insertion, deletion, sorting, and merging. So traversing, anyone can guess what is traversing? Suppose,
Traversing.
yes, suppose you have a graph nodes, or suppose, uh, for example, you think from downtown. Suppose from downtown, I'm asking you to take a route from downtown to Narengi. Okay, then you think
Mm.
about all those bus stops. Okay, now you just tell me what can be the traversing. You have a route from downtown to Narengi. There must be some bus stops in between. So I'm asking
So
you to tell me the number of bus stops
Please
in
repeat it again,
between. Okay,
ma'am. Can you please repeat it again?
yes, sure. Okay, so I'm asking, suppose you have a bus route from downtown to Narengi, and I'm asking you to count the number of bus stoppages. What you will do?
Number of stoppages.
Simple, very simple. You will just take your bus or van and we'll just go from downtown to Narengi. Then every time your van stops somewhere, then you will just count it as 1, 2, 3, 4. Then you will get to know that maybe 5 stoppage or 4 stoppage, right? So traversing is just going through all the required nodes or all the elements in a data structure. Then another example we can take, like for the array, uh, array of 10 numbers. If I'm asking you how many numbers are there and you don't know the size, what you will do? You count just all the numbers one by one, right?
Yes.
Yes, ma'am.
So that means that is also traversing. You are accessing each of those nodes one by one. And if I ask you to find a particular number, then also you will go through all those numbers, right? So that is
Yes.
traversing
Yes.
in very simple way. Then searching, what will be searching? That's very simple, right? Searching algorithm you did it in
We
previous class
will,
also.
yes, we will search a
mm,
particular file for us.
Yes, it's like searching any particular item from a list or array or anything. So searching will be here this time as well, linear and binary search. We'll go through those things again. Then insertion is very simple. You are just adding items to your data structure. Deletion means you are just deleting some items. Sorting means last time you did sorting as well. What was sorting?
So, ma'am, it will choose only the particular files that we wish to get among other files.
No, that is searching. Sorting.
Okay. Sorting.
Sorting is arranging in
Ma'am,
a certain way.
after searching, ma'am, it will distribute.
Arranging items
It will
Yes,
after.
systematically.
yes.
Yes.
Arranging items.
In a
Yes,
Arranging items in a systematically way.
Yes, true. So you can just arrange some items in a systematic way, or if in case of suppose number, it can be ascending or descending way. So I can ask you to or in alphabetic way. Suppose like your name, I can ask you to arrange all the alphabets in alphabetic way, like ABC. Okay. Similarly, numbers also it can be ascending or descending order. So last time you got three sorting algorithms, right? Like bubble sort, insertion sort, and one selection, I guess. So this time you will have more sorting algorithms, but sorting part is like a bit later, like fifth unit. Then there's another one is merging. Merging means that's very simple, right? Merging, merge,
Merging. Merge. Um,
Merge.
merging. How you
it's to
merge?
add two elements.
Yeah, it's just merging two lists. Suppose you have two lists, you are just merging all those elements or just two lists. So these are like main operations. And okay, these are all about like basic things about data structure, means basic terminologies. Then for the part of algorithm, can anyone say more about algorithm, like how it helps?
When it helps a person to understand the way of functioning of a program efficiently.
Yes, correct. Anyone else want to add something? Anything want to add? Means why we need algorithms. Anyone want to answer that? Why we need algorithms? Okay, but tell me one thing. If I'm asking you to write a program, any program, you just need to implement a program, which will be better? If you directly go for the program, or it's better if you write the algorithm first?
We have to write
Algorithm.
algorithm first.
Yes, because suppose you are directly trying to implement a program, then it's not working. Right? If it doesn't work, then you keep trying to run it over and over again, and it's not going to help because the problem is in your algorithm. So if you write the algorithm, then it will be easier for you to track down if there are any errors occurs. Okay? So your root
Yes, ma'am.
programming is all about data structure and algorithms. So data structures are used to hold data while algorithms are used to solve the problem using that data. Okay? And there is another thing, how efficiently you can use them. Means a same program you can write in a many different ways, right? Similarly, an algorithm also you can write in many different ways. So can anyone say what is the difference between program and algorithm?
Al- we cannot write algorithm in different ways.
Ma'am, what was the question? I didn't hear it totally.
Can anyone say
What's the
what's the
difference?
difference programming and
Difference.
algorithm?
Difference between programming and algorithm. Ma'am, programming is the and when we write a certain program to execute something, that is called programming, and algorithm is the systematic way to
Way to
show
write
how
code.
a program works.
Okay, so you can say program is like just set of instruction you give, right?
Yes.
So then algorithm will be
That's
to show
The
how the
concept
set
or
of
idea.
instructions works
Yes.
step by step.
So a program can have many algorithm implementations.
So
So depending on your program style, the algorithm will be different. Then then comes your why it's so important.
Algorithm.
Yes. First thing you have to see the time. Okay. When you write any algorithm or program, you have to check how much time it takes. If you are writing a very long program, of course, it's going to take very long time to process, right? Then it
Hmm.
also depends on the input size. If your input size is very big, then again it will take long time. So if it takes long time, again if your input size is more, that means it is going to take more memory in your computer. So our main goal will be always to reduce the time and the memory, because not all the time we will have good memory, right? Like I'm recording the video, if my memory space is already full, it will be difficult for me to keep all those things. Again,
yes,
similarly,
ma'am.
if you write a program or thing, if memory size is too much, then it will be a problem for you. So we always need to write programs or any algorithm such that it takes less amount of time and less amount of memory space.
Yes, ma'am.
Okay.
yes, ma'am.
So then again another quality should be like scalability. Scalability means
And scalability.
yes,
Scalability.
scalability means
Ma'am, no idea.
okay, scalability means you
Scalability.
can use same algorithm for many, means even if your input size increases, still you can use the same algorithm. Means
Yes, ma'am.
it should not be constant.
Can you
Means
just
using this algorithm or program, you can only use this type of thing only. So it should be scalable for any input data. Your code should be flexible.
Yes, ma'am.
So I guess this
Okay.
meeting is going to end soon. So next part we will again discuss this algorithm part again. This meeting is going to end soon in 5 minutes. Okay. So
Yes,
I
ma'am.
stop my class here. Tomorrow again we'll start from algorithm again. Okay. And all these videos, and for your lab videos, all of the lab videos are already uploaded in YouTube. Lab classes will start from maybe next week, not this week.
Okay, ma'am.
And
Okay.
even the theory videos you will get in YouTube very soon.
Yes, ma'am.
Okay.
Okay, ma'am.
Okay.
Ma'am, we will be getting notes for these classes,
Yes.
PDF notes
Those are already notes already
in the
uploaded in
portal.
ERP.
Okay, ma'am. Thank you, ma'am.
Yeah.